Hello everyone, welcome back to our channel Electro Study. This is lecture series 1 under Embedded C Basic. We are going to see about the introduction of microprocessor. Basically, this Embedded C Basic is a laboratory. We in VTU we have a choice of choosing it as either as a laboratory or as a theory paper. Now, for today, I'm going to explain about the introduction about the microprocessor. Then in these series of videos, you will be seeing about what is microcontroller and some programs related to microcontrollers. Come, let's go into the video. Please do like, share, subscribe, and comment. So, what is microprocessor? So, it is a controlling unit of a microcomputer. That is, starting we had microcomputer, then we moved on to microprocessor, then to microcontroller. So, day by day, there was a advancement in technologies. That is why we are now seeing about the microprocessor, which is a controlling unit of microcomputer. Generally, this microprocessor is fabricated on a small chip where this microprocessor will have the capability of performing ALU, that is arithmetic and logic unit, that is operation, all the arithmetic and logical operation, and it communicates with other devices which is connected to it. So there will be an input device and the output device is the interface that is connected to the microprocessor through which it communicates. And this microprocessor, now you can see the block diagram of microprocessor where it has ALU, register array, control unit, and a memory unit. Now here ALU is nothing but arithmetic and logic unit, where in this all the operations regarding arithmetic and logical operations will be carried out, and the data received from the memory or the input device, this will get into the chip, make the function of all these ALU, control unit, and register array, and then it get back to the output devices. Now when you see here, this ALU is performing all the operations based on arithmetic and logical operations, and this register array is nothing but it consists of all the registers like register B, C, D, E, H, L, and you have a register called accumulator. So these are some kind of register that you can see in register array. And finally, the control unit is nothing but it will be controlling the complete flow of data and instruction within the computer. So this is what your basic microprocessor is, microprocessor block is. So based on this, ALU performance, control unit, and register array, there were generation of microprocessor which was carried out. That is 4-bit microprocessor, 8-bit, 16-bit, 32-bit, and 64-bit. So these are the number of microprocessor generation that you can see. So it started with 4-bit microprocessor, and based on its capability, it has ended up with 64-bit microprocessor. Now here you can see some basic terms in the microprocessor like instruction set, bus, IPC, clock speed, bandwidth, word length, and data types. Now we'll see what is instruction set. So instruction set is nothing but it is a complete set of instruction that your microprocessor can understand. So when as a human being, when we talk in our native language or through English, Hindi, we are able to understand, decode the things that is communicated from one people to the other people. So likewise, your microprocessor will have its own language to understand. So such language is actually, it started with assembly level language. You will come to know what is assembly level language. So that was the language where different instructions were given to the microprocessor in the assembly level language, which the microprocessor can understand. And of late, the microprocessor is able to understand C programming, embedded C, all those. So that type of instruction given to the microprocessor is said to be the instruction set. Bus is nothing but it is a communication channel between the input and the output device. So now here You can see there is a line that is going through all the complete block. So this is nothing but the bus which is communicating with all other devices. Like this, it is communicating with accumulator, it is also communicating with interrupt control and serial input control. So it is a communication interface that is present in the microprocessor. Next is IPC. IPC is nothing but the instruction per cycle. So when you are giving an instruction set, if it is a 4-bit microprocessor, then per cycle you are allowed to transfer only 4 bits of data. So this is based on the microprocessor bit, the instruction that can be fed to it will be decided per cycle. For per cycle, how much instruction can be fed into the microprocessor. Clock speed. Clock speed is nothing but it will be determining the number of operations per second. So when or how the processor can perform the number of operation. So it might be always represented in megahertz or gigahertz. It is otherwise called as clock rate. Next, coming to bandwidth, it is nothing but it is the number of bits processed per instruction, per single instruction. So like if I give add, so if I give add a1 comma b1, then it is said that for adding, how many bits is being transferred per single instruction. So that is called as bandwidth. Word length. Word length is nothing but it completely depends upon the internal data bus, registers, ALU, all those. So if suppose if it is a 8-bit microprocessor, then it can process only 8-bit of data at a time. As I already told you, based on instruction per cycle. So if it is a 16-bit microprocessor, then only 16-bit of data can be processed. So that is how it is. And finally, data types is nothing but the microprocessor has multiple kind of data formats like binary, BCD, ASCII, signed, unsigned numbers. So it can deal with different kinds of data types. So now here you can see there is a power supply which is also grounded, and you will have an oscillator x1 and x2 which will be giving the clock time, and you will have accumulator, temporary register, flag. So accumulator is nothing but the basic register which can store the data, and there are number of temporary registers which also uses the data to be stored in it. Here the arithmetic and logical operations is carried out. This is instruction decoder and machine cycle. So here only the all the instruction that we are feeding into is decoded and then processed. Instruction register, you have a register for instructions and serial input output control. And this is interrupt control. This is when if there is higher priority or lower priority data that is taking in, based on the high priority the data are sent, and same way you have multiple number of blocks available for each of the register or data to be stored in. And next, moving into different instruction set, RISC and CISC. So these are the two instruction set which is called as RISC and CISC. RISC is nothing but it is a reduced instruction set, and this is complex instruction set. So most of the microprocessor will use either of these instruction set. So when you're taking about RISC, you can tell that it is reduced instruction set. So it might require large number of, it consists of large number of registers, and the program is the instruction that is fed in is very less, and the RAM usage will be on the higher side. And being the reduced instruction set, addressing modes also is very simple, and the number of clock cycle will be fixed. If it is a complex instruction set, the number of registers it contains will be less. The program will be smaller, but the instruction set will be on the higher side. You have complex processor circuits. The RAM usage will be little, and the addressing modes you will have variety of addressing modes because it uses different data instruction sets, and the length of the instructions will not be same as RISC. It will be variable. and there will be variable number of clock cycles for each of the instruction. So if you have any doubt, please comment. We'll be addressing you for that particular topic. Please be stay tuned for more information. And this application, so all the microprocessor, microcontrollers, you will have some application. So these are the some listed applications that you can see where it is used in medical purpose, instrument purpose, household purpose. So in different kinds of real-time world, it is being used. So based on its compatibility, it is working on the higher side, many applications. So to see about what is microcontroller, stay tuned for more information. We'll be seeing the next series. Thank you.